Hello sir, my name is K. Lakshmikant Reddy. Subject name Engineering Mechanics, subject code 23ME201. My roll number is 234G180310. Today my topic is law of conservation of momentum, work energy equation for translation. Introduction. The law of conservation of momentum states that the total momentum of a closed system remains constant if no external forces act on it. This law is based on the principle conservation of linear momentum, which is the product of an object's mass and velocity. Conservation of momentum is a fundamental concept in physics and play crucial role in understanding motions of impulsive momentum theorem. The impulsive momentum theorem states that the change in momentum of a subject is equal to the impulse applied to it. Impulse is defined as the force applied to an object over a period of time resulting in a change in momentum. Mathematically, impulse is calculated by integrated the force overcome, while momentum is the product of mass and velocity. Applications of conservation of momentum. Conservation of momentum is used to analyze various physical phenomena such as collisions between objects. In elastic collisions where kinetic energy is conserved, momentum is also conserved. Conservation of momentum can be applied to a complex system involving multiple objects interacting with an other. Work energy principle. The work energy principle states that the work done on object is equal to the change in its kinetic energy. Work is defined as the product of force applied to an object and the distance over which the force acts. Kinetic energy is the energy associated with the motion of an object and is calculated on half the product of mass and velocity squared. Relationship between work and energy. Work done on an object can change its energy from potential to kinetic energy. In the absence of non-conservative forces like friction, the total mechanical energy of an object remains constant. The work energy principle is a powerful tool for analyzing the motion and objects and systems in various scenarios. Work energy theorem for translation. The work energy equation for translation states that the work done on an object is equal to the change in its kinetic energy. The equation is expressed as W is equals to triangle KE, where W represents work done and triangle KE represents the change in kinetic energy. The work done on an object can be positive, negative or zero depending on the direction and magnitude of the applied force. Conservation of energy in translation. In absence of non-conservative forces such as friction or air resistance, the total mechanical energy of an object remains constant. This conservation of energy principle allows us to analyze the motion of objects in various situations without considering individual forces. By applying the work energy equation for translation, we can determine the change in kinetic energy of an object due to external forces. Examples for work and energy in translation. A simple example of the work energy equation in translation is a block sliding down an inclined plane. The work done by gravity on the block is converted into kinetic energy as it accelerates down the slope. Calculating the work done and the change in kinetic energy allows us to analyze the motion of the block along the incline. Real world application. The work energy equations for translation is used in various real world applications such as designing roller coasters. Engineers use this principle to optimize the design of roller coasters to ensure a thrilling but safe ride for passengers. Understanding the relationship between work and energy in translation helps in analyzing and improving the efficiency of mechanical system. Conclusion. In conclusion, the law of conservation of momentum and the work energy equation for translation and essential concepts in physics. This principle helps us understand and analyze the motion of objects and system in various scenarios. By applying these principles, we can predict and optimize the behavior of physical systems, leading to advancements in technology and engineering. In conclusion, the law of conservation of momentum and the work energy equations for translation and essential concepts in physics. These principles help us understand and analyze the motion of objects and systems in various scenarios. By applying these principles, we can predict and optimize the behavior of physical systems, leading to advancements in technology and engineering. The law of conservation of momentum and the work energy equation for translation and essential concepts in physics. These principles help us understand and analyze the motion of objects and systems in various scenarios. By applying these principles, we can predict and optimize the behavior of physical systems, leading to advertisement in technology and engineering. Thank you, sir.